Different cultures have named it Jove, Marduk, Zeus, the Wood Star, Guru, Thor, or just plain old Jupiter. Whatever you call it, it's a gas giant, with a mass 2.5 times that of all the other planets in the solar system, combined. However, most of us only know it for its big red spot, which is a centuries-old storm that could swallow the Earth whole. But this planet has so much more to tell, with a gravitational field that has helped shape the solar system, 79 natural satellites, 4 sets of rings, and a powerful magnetosphere. Want to know more? Then head on through this door to discover the undisputed king of the planets. Ganymede is composed of approximately equal amounts of silicate rock and water ice. It has an liquid, iron-rich core, and an internal ocean that may contain more water than all of Earth's oceans combined. The outer crust is made of a layer of hexagonal ice. Beneath this lies a saltwater ocean sitting atop tetragonal water ice. Then comes a rocky mantle, within which sits a core made of an outer layer of molten iron and iron sulfide surrounding a solid iron inner core. Its surface is around 4 billion years old, and composed of 2 main types of terrain. Dark regions, saturated with impact craters, and lighter regions, crosscut by extensive grooves and ridges. The cause of the light terrain's disrupted geology is likely the result of tectonic activity due to tidal heating. Ganymede orbits Jupiter at a distance of 1,070,400 kilometers, taking roughly 7 days to do so. Interestingly, this massive moon is also in orbital resonance with 2 other of Jupiter's moons, Europa and Io. The formation of the grooved terrain on Ganymede's surface is likely a result of more significant tidal heating processes in the past, potentially linked to a larger eccentricity. Being tidally locked with Jupiter, Ganymede always has one side facing toward the planet, hence its day is the same as its year. 7 days and 3 hours. Because Ganymede's orbital eccentricity is low, tidal heating is negligible. Yet there is still enough to account for the existence of a liquid subsurface ocean. Like the other planets of our solar system, the interior of Jupiter is made up of various layers of material. The first layer is obviously the outer cloud layers, which cover an inner layer of predominantly gaseous molecular hydrogen. This is followed by a liquid hydrogen layer. Then, a liquid metallic hydrogen layer. And finally a dense core made of metal, rock and ice. Gallivanting wombats. You've blown me away. Here, have this info nugget as your reward. As humans colonize the solar system, we will have to find new ways to harvest energy. Two interesting options Jupiter offers are utilizing the heat energy emitted from Jupiter, and harnessing the electric current generated as bodies move through Jupiter's extraordinarily powerful magnetosphere. In January 1610, Galileo Galilei made a groundbreaking astronomical discovery. In short, he found that Jupiter has moons. The discovery of the Galilean moons, as they came to be called, caused quite a stir. Because scientists still believed that all of the heavenly bodies revolved around the Earth. Knowing that another planet could itself have bodies orbiting it, was nothing short of revolutionary. All four of the Galilean moons are so large, that if they were in direct orbit around the Sun, they would be considered at least dwarf planets, if not actual planets.